Okay. So the idea today is, by the end of this workshop, this hour and 40 minutes that we have in front of us, you will understand what is a container, why you would want one, how to create your own containers with Docker, how to share your containers, and we're going to have a look at how to create multi-container applications and multi-host applications. Now, that's perhaps a bit ambitious for an hour and 40 minutes, but we'll do our best. It might be, well, we'll see where we go. So yeah, Docker machine is the simplest way to get started if you don't have a Linux machine. So is anyone currently using Docker in production? Okay, there's a kind of tentative hands. You're not sure, or you're not very. Yeah, I think that this is the fun part because Docker's still relatively new technology. It's only been around for a couple of years, even if the underlying mechanisms that Docker uses have been around for a long time. And also, the Docker project is moving very fast. Things are changing at quite a fast rate. So the Docker that you perhaps used 1 year ago is a different Docker than today. So what is Docker? This is what Docker Inc. says Docker is. And according to Docker Inc., Docker is a platform for developing, shipping, and running applications. For them, it includes Docker as in the command line, the engine, the tool for creating and managing and running containers. But it's also the hub, the trusted registry, the Docker machine, Swarm, Compose, Kitematic. Basically, their whole ecosystem is what they consider to be Docker. Well, it's their project. They get to choose what it is. So, what Docker is for me is it's a means to package an application together with all its dependencies into a standard unit of software development. It's basically creating a box that you can ship around to make sure that software will run with all its dependencies wherever you want to run it, be that in development, in testing, in production. As well as that, it provides isolation. This was one of the main reasons why John was using, why John introduced Docker to the CyberDojo project was because we wanted to isolate basically running people's application on our server. So running people's code, executing people's code on our server. So we wanted to make sure that there was a limit to the damage that could be done. So there's this isolation, and that's also to do with dependencies as well. If you can isolate something, then you can manage its dependencies. And the thing that's special about Docker is that it also, as well as creating the standard of work, it makes it very easy to be moved around. Because you could say that a virtual machine, for instance, gives you a way to manage, to package an application with all its dependencies with isolation. But moving around virtual machines is not the same story as moving around Docker images. So for me, that's the pitch. That's why I'm interested in Docker. As well as that, if you speak to Kelsey Hightower, the guys from HashiCorp and Mesosphere that are here today, they have different reasons for being interested in Docker. They think about it in terms of, I have 100 billion trillion machines, and I'd really like to use as little electricity as possible. They're basically optimizing for what? And the way that they want to do that is instead of having to have a whole virtual machine operating system for every application to get isolation, if they can use containers, they can pack many more workloads onto their servers. So for those of you that have installed Docker, can we just go ahead and type in Docker info and make sure you've got a live system up and running? And I'll do the same. Let me make this a bit bigger. Well, Martin, can you see that in the back? Is that big enough? Bigger. How about that? More? Okay. Just shout if your eyes get tired. So Docker info, what does that tell us? Well, a bunch of stuff about our system. So I've got 6 containers running. I've got 205 images. This is my server version. 1.9 was the release made a couple of months ago. I implore you to upgrade to it. It's got a bunch of really cool additions that are very, very helpful, and we'll take a look at some of them today. So please, if you're not at 1.9, now would be a good time to try and upgrade. Here, this native execution driver, that tells us we're using libcontainer as the containerization technology. That is a pluggable choice in Docker. You could use LXC, and the future will probably involve the SDGels and all the other container possibilities out there. As a sidetrack, Microsoft has done an awful lot of very interesting work on making containers work on Windows. So I recommend, if you're interested in running Docker workloads on Windows machines, to go to the next session here. Anything else? I guess from my perspective, I'm using boot to Docker, which is to say that because I'm on a Mac, there is no native Docker support. So the way Docker works on a Mac and up until recently on Windows is to run it in a Linux virtual machine. And that's the boot to Docker virtual machine. That's where all these things are executing. Yeah, that's about all that's interesting. Everybody got a working Docker install? Yeah. Very good. So, Docker version. Let's create some containers. Docker run hello world. So, that was fast. A lot of things happened. Hello from Docker. This message shows you that your installation appears to be working correctly. What happened in order to run this was that we actually ran a container, and the Docker daemon pulled that container created the container from an image. We'll talk about that in a bit. And that image was pulled from the Docker hub. And then we executed the default command in that container, which was to print this message. So here's a better picture of what just happened, and a little bit of an introduction to the architecture of Docker. So Docker has a client. This is what that's what you're communicating to when you type Docker commands in your command line. You're using the Docker client. And that's where you issue your commands: Docker build, Docker pull, Docker run. This is how you talk to Docker. But there's also a Docker daemon, which is running as a service on your Linux machine. And the Docker daemon accepts commands, and from those commands, it will run containers. Containers are this isolated work unit we've talked about. So for instance, with the hello world example we just ran, we did Docker run. So we asked the daemon to run a container called hello world. It didn't find the image locally, so it went to the registry, went to Docker hub, which is the default registry configured. It found there an official repository called hello world. It pulled that repository down into the local cache of images, and then it ran an instance of that image, which is called a container. The container created that output and exited. So this, in a nutshell, is what Docker is. It's nothing more and nothing less. It's a very simple technology. In fact, I do a lot of training courses, and Docker is probably the least fun one for me to give because there's not much to teach, right? This is it all in a nutshell. Other than this, it's just to figure out how all the tools work. Yeah, so commands are executed on client, images are pulled from repositories, and containers are run from images. That's the words you will be thinking about when we go on today. So again, a container is an isolated and secure application platform. You can run a container, you can stop a container, You can start a container, you can move a container, and you can delete a container. And the containers are created from Docker images. For the programmers in the room, you can think of an image more like a class, and a container as an instance of that class, if that helps. For the ops guys, I don't have a very good metaphor, but you can think of something. Let me know. So we've talked about it. There's a thing called Docker Hub, and Docker Hub is a website. Let's have a look at Docker Hub. Docker Hub is a website full of image repositories. So if you don't have a Docker Hub account, I recommend you get one. They're quite useful for doing a bunch of things with Docker, especially if you want to push and pull your own images. So for instance, if we wanted to have a look at this hello world repository we just ran, and there you can see it's there. There's not much to say. We'll get a bit more into images later, but it's enough to know that there is a thing called a registry, and it contains repositories like Hello World where you can pull images from. Yes, good question. So the question is there any versioning? And there is versioning on every single image layer has a digest, but on top of that, when you push an image, you push it with a tag. And that tag is kind of like a version. Usually people will use a tag. There's the default tag, which is called latest. So if you pull, we'll get into this in a little while, but if you pull something without giving a specific tag, you'll get the latest version of that image. Or for instance, if you were to do Ubuntu, you could type Ubuntu :14.4, and then you would get that specific version. So let's have a look at what images you have. If you do Docker images, you get a list of all the images you have on your machine. And you can see it's been a long time since I pulled the Hello World, so I don't even think it makes it on the list. There it is, way down there. So my Hello World was from 3 months ago. So my Docker run didn't pull it. This is an important concept. One of the reasons why Docker is so fast is that it does an awful lot of caching. So I ran the Docker Hello World on this laptop when I bought it 3 months ago, and it's been using the cached version ever since because the Hello World repository in Docker Hub has not been updated. So it doesn't need to pull anything. But for you guys, if you've never run Hello World before, it should say something like, I don't know, 2 minutes ago or something. So yeah, Docker will attempt to use the local image first, which is what it did with me, and maybe for some of you also. And it will look to the hub if it's not found. So the images are specified by repository tag. We saw this, and the default tag is latest. An important thing is, I did say that it's a version, but it's not really a version because it can move. Let's take a look at Ubuntu. I'm a continuous delivery consultant, so I'm very particular about what a version is. But for instance, if you take a look at the tags for Ubuntu 14.4, I mean, what you actually pull when you pull Ubuntu 14.4 has changed as security patches and so on get added. You get kind of the latest of that tag. It's more like a branch in Git than a commit chart, if you want to think about versions. So here in Ubuntu, we have an awful lot of images. Typically, we'll use 14.04, but more and more people are moving over to 15. It can be a problem. It depends on your application. So, I mean, whoever's releasing the images that you're using, that's the process you have to think. You might have your own base image, in which case you can control how those updates happen and how they're rolled out. But yeah, we've seen applications break because like for instance, the Ubuntu, something changed, or perhaps like the first line in the Dockerfile was to do an apt-get update, which created some incompatible packages. So yes, configuration management is hard. Yeah. So let's saturate the network. Let's try and run something a bit more interesting. Docker run Ubuntu, Docker run Ubuntu colon 14.04 echo hello day of Docker. Thanks. Yes, bash, my friend. Can't get too shouty with bash around. Oh, okay. Can't win them all. Anyway, so this is the same thing. I happen to have an Ubuntu 14.4 image locally, so I didn't have to pull any file system or any images. But I'm pretty sure I don't have a 15.04, so let's have a look at how that changes. So I don't have this image locally, so it's pulling the different layers of the image down from Docker Hub. And then it takes a little bit more time the first time you pull an image. Are you guys saturating the network? You're on a different network from me, so I don't have a feeling. Is it working? No. Are you guys completely stuck? It's working. It's surviving. I think once you get down Ubuntu 14.04, the rest of the session will be fine. But seems my network's not so impressive. Yeah, and it's not so important. Anyway, I just wanted to show that like if you don't have an image, it does go to the hub. But I guess you all are acutely aware of that at the moment. Yeah, so let's have a look at this. What we've done is told Docker client to execute the run command. We've said this is the image we want to run a container from. So that will, if it doesn't find that image locally, it will do a pull from the default registry, which is hub for you guys. And then we've told it, when you run that container, execute this command, which is echo hello world, or psaux. Actually, psaux is quite an interesting one as well. Let me just... Okay, Docker run into 14.04. So, interesting thing about when you run a Docker container and run in a Docker container is that the process that you run is actually running with PID 1. This is to do with the way the namespaces work in the container, and we have what's called a PID namespace. So inside the container, you're the only thing that you see. I mean, obviously, if you spawn children and so on, they're part of your tree. But you don't see any of the other processes on the system. As far as you are concerned, in your container running your application, you're the world, and there's nobody else on this machine. Getting there. Okay. So let's run a container with a terminal. Same thing. Let me make that big for Ollie Martin in the back. So we want to tell Docker that we also want to have an interactive terminal. We want to have an interactive terminal, and we want to run bash. So here we are. We're in our container, and if we do a ps, let's see, you can see that we are in our little world, in our container. So you see, we have a digest, an ID for our container. There's a this is a shortened version of the actual SHA. Every container has its own ID like this. So let's add something to our container. Git install vim, because I know it will bother Christian. Yeah, I definitely want to continue. Yeah, so now I'm in my container installing Vim on top of Ubuntu. It's going to download this stuff from the Ubuntu repositories. So now we should be able to do Vim and wait a minute. So I'm going to create a file called hello, and I'm going to say goodbye, because that's how developers work. So we see now we have a file called hello on our file system. Yeah. So, and actually for fun, we can just rm-rf bin. Let's make a look at that. Yeah, so we don't have ls anymore. Let's go ahead and exit that container. So if I start a new container on that image, we'll find that there is no vim, and obviously our /bin directory is there. So any changes we make in our container on the file system, or any kind of side effects we have, are isolated within that container, and they only survive the length of the container survives. Does that make sense? Yeah, you can also escape from a container. So let's, if I do Control and P and Q, I get back to my host shell. I'm outside of the container. I can do a docker ps, and I can still see that the container is running. Yeah, and we can also do a ps -ef. And we'll see that that bash terminal that is running in the container is actually visible outside of the container. So it is just a regular process from outside the container. It's only inside the container that you have this isolation. So if you log into a virtual machine that's running 15 containers, you can do a ps -ef, and you can see all the applications that are running. It's just that they're contained in their containers. That's Control plus P plus Q. It's kind of like the cheat code in the computer game. So another thing is that inside the container, your process is PID1, but outside of the container process, the PID is something else. It would be 503 or whatever. So we have docker ps, which we already used to have a look at our containers, but we can also docker ps -a, and that will show us all the containers, even the ones that have exited. So you can restart and execute an exited container. So in production, it's actually more likely that you'll run with --rm, which says remove the container when I'm done. So here we have a container called 15b39. If I exit now, that container will not show up here. Yeah, see, we don't have that 15b39. Because in general, you don't want all those containers lying around in your system. Oh, you can exec or attach. We'll come to that bit. Yeah. Yes. So you can give a container a name, but that's not really the host name. It's just the container name, and that's what. But we could, for instance, we could say dash dash name. I think name equals like, and then if we do control PQ. What's going on? Interesting. Oh, there we are. Docker PS. See, now we have a name. By default, a container gets an ID, which is the SHA, and it gets a name. And Docker will generate a name if you don't define one. But you could also specify what the name for that container should be, such as DB or Webfront or Nginx or whatever makes sense for your application. So it's a good practice to give your containers names. So normally you don't run your containers interactively. You run them because you want to run a service or some kind of daemon. So what we can do is we can run a container in the background with a -d. Let me just, docker run -d. To 1404. Ping-c. How is it now? Yeah. So I'm going to ping localhost in my container, and I'm going to ping it 30 times. So there I have a container. This will be its ID. So if we do a docker ps, we can get that list. We can see that it's running there. It's been given a name, gigantic gates, and it's been up for 5 seconds. If we do docker logs gigantic gates, we see that it's going through the pings. And we should see that now that has exited, almost. Yeah, now it's gone. Yeah, so to get by default, Docker will capture everything that goes to standard out, standard error, standard what have you, into its logs, and then you can retrieve those logs with the docker logs command. Let's try. Seems so. So that's what it means. Like the container hangs around after it's exited. It might not be a running process, but all its data and so on is still there. So you can do the docker logs, you can restart it and so on. But you should also remember to go and clean up. Okay, now let's try and make something a little bit more like a real system. CD docker. Actually, I don't need this CD. So let's run an Nginx. We're going to run it in the background. Yeah. So an important thing here is what we want to do is give the -p command. And what that tells Docker is we want it to expose the ports that the container exposes. So an Nginx will typically run on port 80 or port 8080. If we do a -p, that will tell Docker that if it does open the port that it says it's going to expose, we want it available outside of the container. Without that, the there's no way for the container to speak outside. So there we have our Nginx. We'll do a Docker PS. Again, we'll see that. And we see the ports have been mapped as well. So we have port 32769 mapped from port 80 inside the container. And we see that the SSH port is also mapped. So I'm running Docker machine. It'd be handy to have a piece of paper here. But the idea is that Docker machine, I'm running Docker inside a virtual machine. I'm not actually running it on my Mac box. It's running inside a virtual machine called boot to Docker. So normally, if you were on Linux, you could just go localhost and then whatever that port was, 32769. And then you would get access to Nginx. But what Docker is doing is it's connecting into the virtual machine and running its commands. So that port is exposed in that virtual machine. And that virtual machine has its own IP address. It's not the same IP address as your laptop. So it's Docker is a lot easier on Linux native, obviously, but we can solve this because I'm using Docker machine, so I can just do Docker machine IP, and it's the default machine I'm using just now. So this is my IP address for the virtual machine that is running my containers. So instead of localhost, I have to put that IP address in, and then I have an Nginx. Just out of interest, how many people are using machine, and how many? Yeah, put your hands up if you're using machine or a virtual machine to run your containers. Okay, and how many people are you got native Linux? Okay. You have a question?
You can actually make it work with localhost if you configure port forwarding on your virtual machine.
Right.
So if you open VirtualBox, process network and open those ports, then it will work with localhost as well.
Right. Yeah. So the point is that you can do port mapping in VirtualBox to forward those ports, but by default that's not the case. Okay, so we have our Nginx running. It looks great. It's in a container. Now, onto images. So images are the really interesting part of Docker technology, if you ask me, because containers have always been around, the C groups at least, and BSD jails, Chroot, all these kind of isolation technologies have been around for a long time. But the thing that Docker adds one is a user interface to encapsulate all those different isolation namespaces, but also it adds the images concept, and this is very key to what Docker is. So again, like I said, all containers are made from an image, and an image is basically a read-only template for creating containers. It's what a container is made from, instantiated from. You use Docker build to create an image. We'll get to that later when we have Docker files to build our own images. They are stored in registries, like Docker Hub, but you can also have your own registry. And you can create your own images, and you can use images distributed by others. In the hub, there are lots and lots of images, and there's also what they call official images, which are images supplied by the projects themselves. Like, for instance, Apache project has an official Apache image that they support. But it's important to understand that it's not Docker Inc. that's saying it's official. It's the open source project that is in charge of saying this is their official one. So images are layered read-only file systems. So the idea is that on top of your bootfs, like your kernel, you'll run a container, which includes a base image like Debian, like Ubuntu, like BusyBox, whatever you choose as your base. And then you add layers to that image such as applications and so on, like Emacs, Apache, Nginx, what have you. And each layer in the image references its parent. So there's the base layer. A common base layer in Docker systems is Debian or BusyBox. BusyBox is a very, very small Linux, but you can also have CentOS, Red Hat. There's Mint. We've already played with the Ubuntu base image. And then when an image is run, a container is made, what happens is a writable layer is added, and that's per container. Every time you run an Ubuntu Docker container, it gets a writable container. And that's how we're able to create files and delete things and change things without affecting the image. This is the copy on write file system that's used. So you don't have to run an image to get an image. We, for instance, here we did a Docker run Ubuntu in order to get the image locally as well as to run it. But if you just wanted to, for instance, prime your cache, you could do a Docker pull Ubuntu 15.04, and it will pull it down for you. But since my image is already up to date, it doesn't pull anything. So let's make an image. There's two ways to make an image. The first one is the one we really recommend you not to use, but it shows you the concepts of how Docker makes its images. So we can, for instance, let me start a container. Let's log into a container with bash. So I need to remember that I need the teletype and the sudo terminal. So there I have, oh, that was silly. Okay, I don't want to run it as a daemon, of course. I want to actually log into this guy. So here I am in my Ubuntu container. And say I like Ubuntu containers, I'd like to have an Ubuntu container, but it really ought to always have Vim and curl installed because they're what I use every day. So let's do git install Vim, curl, yes. So now I should have curl installed. Yes. I should have Vim installed. Yes. Now I'd really like to keep this around. I don't want to have to install this every time I start an Ubuntu container. So remember Control P and Q breaks me out of the container. Now we can do a Google commit? No, a Docker commit. We need to know what our container ID is, or we could use the name, which is ecstatic McCarthy. I think I'll use that. So let's make a Docker commit ecstatic McCarthy. Say that 3 times. And now we have to give it a name. Typical name is to start with your username or your company name. For instance, in Docker Hub, / the name of the application, and then also give it a tag. So here we give it 1.0. If we don't give it a tag, then by default it will be the latest. Yeah. So Microsoft It's going to be 1.1. This is my 1.1 version of my image. There we go. Yeah. So now we can, there's a command called docker images again. We can have a look. There we have my images in the list. So we have the repository Microsoft MyApp, the tag 1.1. No, this is only local. This is on this machine. So as well as there being a pull from hub, you can do a push to a registry. We'll come to that when we start to play a bit more with Docker Hub. I'm sorry? Bigger. Yeah. Yeah, I think one of the drawbacks of the Docker user interface is it's designed for either a huge monitor or a small font. Okay, so that's our images. Just yeah. In what respect? So the Microsoft.myapp, that's the repository. That's like the name of the image. So the standard way of naming an image would be the username or your company name slash the name of the thing that's going to run, some description. And then the 1.1 is a tag. And that's like, we discussed a little bit about tags, but tags are like a version that you care about. So this is how you typically name an image. So it's not really structured, but on Docker Hub, for instance, you have to push your image with a name that begins with your username. So I couldn't push something called Ubuntu/myapp to my hub because I don't have access to that namespace, if you like, on hub. So, okay, now I have my image. There it is. I'm going to run it. I'm going to do a docker run. I still want an interactive terminal, and it's going to be version 1.1, and I'm going to run bash. And with any luck, there should be a curl here, and there should be a vim. And that's how you make an image. Now, that's one way to make an image, at least. So one of the downsides of making an image is that, like this, is that it's very hard to reproduce, right? If you download a base image, you log into it, you add files, you delete files, you move things around, and then you do commit and you say, hey guys, use this. Like, it's not the way we like to do things in our modern times. But this is another thing that Docker can help solve. It's the dockerfile. And the dockerfile is a way to, it's a configuration file to build Docker images. That's all it is. There's no magic here. It enables configuration as code. One of the nice things about a Docker file is that you can put it in a version control system, and you can review it, and you can share it, and you can fork it. So you get this configuration as code. If you wanted to rebuild an application environment from checking out a project from 2 years ago, if it has a Docker file and it was running, you can be pretty sure you'll still be able to run that application. It's much more effective than using commit because you can share the configuration rather than the image if you prefer to do that. It's a lot easier in terms of continuous integration. So for instance, if you change your dependencies, you can change your Docker file, push that to your version control system. Maybe Jenkins picks it up. It builds a new Dockerfile. It runs your application. You do your tests. If all the tests pass, then maybe then you push that image somewhere to share. So here's a simple Dockerfile for my app. Instead of doing that commit stuff, let's exit this guy. So I'm going to. Do I already have it? Yeah. Okay. Let's delete it. I don't like you. Let's create a Dockerfile. So the first thing is we need a from instruction. This is the base image. If we go back to this slide, we need to pick a base image, something you're basing this on. That's not 100% true, but for today's talk, we'll say that that's true. So from, and then the image we want to use as our base. So from 1404, we want to run a command called apt-get install. We probably want to put a -y here so it doesn't stop and ask us whether we want to really install it. And then we're going to install curl and vim. Yeah. I mean, it's not a complicated proposition. So let's have a look at our Dockerfile. That's what it looks like. Now the thing is, we need to change. We need to actually build an image from this Dockerfile. Yeah. Okay. We'll get to that. One of the interesting things is we talked about this layered system. What a Dockerfile actually does under the hood is that it creates a container. So, like, to actually build a container based on this Dockerfile, Docker will go through some very simple things. It will do basically like what we would do if we were humans actually creating this container with commit. It will do a run Ubuntu 14.04. So that will do a Docker run 1404, which will create a container. And inside that container, it will execute this command, apt-get install -y curl. Then it's going to commit that container as a new image, an image layer. And then it will create a new container out of that image and run this command, and then do a commit, which will create another container. So this image will have 3 layers. The base image, the curl image, and then the vim image on top. And they kind of point to each other with a parent relationship. That's probably not what you want to do. It's probably you want to do all that in one like this. Normally you would try and minimize the number of layers in your image. Basically, things that are together should be in the same image, the same layer together if possible. Clean up in what sense? Yes. So at least the image layers are not cleaned up because they're actually what form your whole image, right? But the containers that you make during the build process, they all get cleaned up. Okay. So let's build this. There's a Docker build command, of course. What we do is we give it a -t, which is to say, I want to use this tag. If you don't specify a tag, then Docker will just generate one for you, and that's not normally what you want to do. And then you also have to specify the build context. We'll talk a little bit about that just now. So docker build -t, username, name, oops, excuse me. And then we want to say it's going to be version 1.2, for instance. Now this build context is quite interesting as well. Under the hood, Docker wants to have reproducible image builds. So that means everything that should go into the build should be within the current directory or below it. And what it'll do is it will actually make a tar file of everything underneath your current directory, put it in a tar file, and send that to the Docker engine for when it runs and creates the Docker file. So let's do that. Oh, built. I'm living in the past. There we go. So here we go. We have from Ubuntu, it's created this this image. This is the first layer. And then it does the apt-get update and install. And it creates this new layer. So this is the new layer. So if we do Docker images, we'll find that the latest one we built was where is it not there? Ah, there it is. Aha, interesting. It's reusing, I've done this a while ago. It's reusing an old one. So I'm going to give my new app. Yeah, how'd you like me now? Okay. Ah, but it's got the same contents. Ah, let's have a look. Yeah, it's got the same contents of an existing layer, so it knows that it doesn't need to rebuild anything. Docker's being too clever by far. A bit ahead of schedule. Docker RMI will remove an image. That's also true, yes. There we are. Did that do it? Yeah, it's gone. Okay, let's try again. Ah, using cache. Okay. Well, you guys are not using cache, I presume. Ah, this is another way I can cheat. Honey, I don't like where this is going. We're not going to install Emacs. So I'm going to add an MD, a README. Okay, there we go. Good. So you notice actually that because we've added a new command, let me just cut that dockerfile now. So I've added this extra run command. We actually have an extra layer. So it actually did reuse the cache from the previous my app. But now, because I have an extra command, it's an extra layer, and it's just reusing all the other layers it already knows about. The caching in the layer system is actually how Docker manages to go so fast. So go ahead, make your image. In the Dockerfile, there's a lot of things you can do. There's a lot of things you can't do as well. But let's focus on the positives. First thing you can do is you can can specify a command that will be run when the container is executed. For instance, if we were to run Ubuntu, if we were to run Ubuntu 14.04, it already knows that it runs a bash shell for me. And I didn't tell it to run a bash shell necessarily, but inside the Docker image, it has a default command specified with a command. So we could change our one to include a ping. So it takes a JSON array. You can also specify it as just a regular string. So we could just do ping 127.0.0.1-C10, for instance. And that's fine, but there's some good reasons not to do it like that. One is that you want perhaps to have a thing called an exec instruction as well, which tells the command that must be run. For instance, you might want to say ping must always be run, but the user could optionally supply parameters. We'll come to that. But in general, it's a good practice to specify your commands as the JSON array format. So now if we build and run, now it's by default, if I don't give any arguments, it will run the ping command that we specified, and then the container will exit. But I can still write bash here, and instead of doing the ping, oh yeah, I should probably do it interactive. So I can still choose to run a different command on a container than the default. So here's the point about the entry point. So let's add an entry point. Rebuild. So now we've added an entry point. If I run it with no parameters, it does the ping as normal. But it cannot be overwritten. So if I try and run bash, it's going to supply bash as a parameter to ping. So what it's saying is, anytime we run this container, the first part of the command is going to be ping, and any parameters that come after it are supplied by either the command instruction or on the command line. So for instance, if I do ping 8.8.8.8, for instance, now I don't have to type ping here, but I just have to give the parameter. So this is a way that typically people would create a, if you like, an executable Docker image, for instance, to do some utility work. So some other things you can do in Docker files, exposing ports. We saw that Nginx exposed port 80 and port 443. So when we do the -p, those ports get mapped into our host. You can specify environment variables. You can copy files and you can add files. There is a small difference between copy and add. In general, just use copy. Don't ever use add. It's not very useful. It's basically exactly the same as copy. You can also add a tar file and it will extract the tar file for you. Which might sound like it's a lot simpler. Everybody's life is a lot easier because Docker files typically reside as a version control system. I'm not a fan of putting tarballs on version control system. So if you want to add files to a Docker project, I recommend just having them back in the version control system. Some best practices for Docker files. Containers should be ephemeral. That means they shouldn't be designed to live forever.
You should be able to start and stop them, move them as you please. And in that sense, they should kind of be a stateless thing. You can use a Docker ignore file, much like a git ignore file, where you can say, yeah, I have this huge context for my Docker build. You don't have to take everything. Ignore all these directories, because if you have some big directories in your build context, it can really slow things down unnecessarily. Obviously, it's good practice to avoid including unnecessary packages and dependencies. Don't include utility programs and so on. Don't include SSH. Don't include any kind of dependencies that you don't actually need in the normal running of your container. There are other solutions to get access to a running container and have additional tools. Only run one process per container. This is more of a container best practice than a Dockerfile best practice. But the PID1, the whole abstraction that Docker provides is kind of based on the idea that each container will have one process. You want to try and minimize the number of layers as makes sense. You can think of layers in your system as chunks of reuse. So if you have very fine-grained things, all with a parent-child relationship, you can never reuse those things. So try and think coarse-grained when it comes to layers. On the other hand, don't overly fret about it either. I mean, don't sit and optimize the number of layers in your system. It's not that important. And use the build cache to your advantage. Try and use similar base images where it makes sense. It might make sense that you have a family of applications that could share a base image. That would be a sensible thing to do. Okay, so we've got containers, but now we need to manage them. We've done the daemonized run, but we can also stop and start containers. Let's do that. Let's have a look. What do we have currently running? Ah, everything's running. I need to stop some things. So we can Docker stop that one and that one. Oh. Thank you. And I guess I don't need you either. Unless are you running over here? No. Okay. And then I'll stop those containers. Maybe I want to restart one of those containers. Let's try. Yeah. And there it is running again. Nothing too special. But this can be quite a useful restart mechanism. So we can also get terminal access to a container. For instance, we have our Nginx container running. It's running Nginx, but how do we get in and have a look what's going on inside? What we can do is we can do an exec on the container, so that's going to create a command on that container. So let's do that. We want an interactive pseudo teletype, and we want to connect to
this container, the nginx container, and we want to run bash. Because by default, if actually I'm not so sure. But anyway, when we do an exec, we want to say what command we want to run. It might be we want to just cat the logs, or it might be we just want to touch a file. But normally what we want to do is get a bash terminal and have a look inside. So now I'm inside my nginx container. Let's have a look around. Yes? So the thing is, if someone already has access to your Docker engine, like if they're basically logged into your machine, they can do anything. There's nothing like the Docker. The Docker system doesn't really help or stop. Like if you were to run these applications outside of Docker, you'd be in the same situation if someone logged into your machine. Like as long as they have access to your host, then everything's gone.
You can't access it from remote, right?
Well, I mean, that's what I mean. If you get into the host, if someone manages to get into your runtime host, then they can do anything. They can just remove anything. So there's nothing special about Docker that can help in that situation. All right. So let's pop out of here again. Oh, one other thing. While I'm in this container, we can do a PS. And we see that the nginx processes are there, obviously the PID1 and its child process. But now we also have our processes running in that container too. Yeah. Ah, yes. Good question. Let's do that. So there is a thing called docker attach. So let me just do a PS. So the question is, we have this Ubuntu running, and I don't want to execute another application. I just want to attach to the current process that's already running. So let's do that. I don't need that. So here I am in the container. So obviously when I exit now, well, that container is no longer running because I've exited the process that was the thing keeping that container alive. But yes, that's how to do it. Use the docker attach. Okay, so we have one running container, but we also have a bunch of dead containers messing up our clean system. How rude! So let's remove them. Docker ps. So we can just docker rm one by one, but if I do psq a. So these are all the containers. Let's do something like this. So give us a list of all containers and make sure you go and remove them all. So the one of them didn't get deleted, obviously, because that's the nginx container. It's still running. You can't remove a running container. You have to stop it first. But now if we do docker ps-a, we should just have our nginx. Cool. Hmm. Yes.
Okay. But still, since all processes containers are visible to the process list on the host, there is no way to prevent, let's say, user A to see that user B is running process something in his own containers. Is it correct?
So if the user can access the list of all the processes, they can see what other people are running. Yes, that's in general true of any multi-user system. So, okay. Okay, I'm not gonna pick a fight with sysadmins because you guys know way more than me. But I'll say this: what you can do is you can add a user to the Docker group, and you can give them the isolation like that. They don't have to be root user or have anything other than that. But normally in a production system, it would be, I guess, I'm taking a guess here, but I'm guessing that it's IT admins that will be deploying and running. It won't be 50 people all logging in and running their containers on a Docker engine. Especially in production websites and so on, there'll be a system in place. So it won't actually be people logged in doing stuff.
And I have a second question, also regarding processes.
Mm-hmm.
I guess you're using Docker in production. Did you ever get to stop so many tables into a machine that you have exhausted the process table?
No, I have never exhausted the process table with Docker. Sounds like fun. Why? Well, I'm curious why you ask. Is that is that a common limit?
No, so, one of the, I'm trying to, as a sysadmin, I'm trying to understand Docker in a way that I can support developers. So prepare something good that they can use
Right.
in the best way.
Yeah.
And since one of the points of Docker seems to be that you can achieve an higher density than you can with normal virtual machines,
Mm.
So I was wondering if anyone had managed to stop so many that, yeah, it was a bit too much.
I don't think so. So the question is, have people put so many Docker containers that you exhaust the resources of a machine? And so this is a challenge for Docker. We can take that a little bit later, but like when you start to think about clustering and like how to schedule your containers on different machines, there's different approaches. There's what's called bin pack, where you don't give CPU limits, but you give memory limits or other kinds of limits on the container. So normally you would, in production, you would also want to have some constraints on a container and say, okay, this container has 500 megabytes. And you can say what you want to happen at that limit. Is it a soft limit? Is it a hard limit? And then you say, okay, well, if you have this much memory and you have these containers which all require that much memory, you can pack 8 containers per machine like this. There's a whole story about running Docker in operations that's probably outside of the scope for this talk.
So for the Docker images we can download, is the dockerfile included, so that we can say, I want something very similar to this, but I want some customization, so I can make a copy.
Yeah. So let's take a look. So in Docker Hub, let's just have a look for a CyberDojo. I don't know if it's actually built. I guess this one. So here we can get the, hey look, I'm the maintainer apparently. So yeah, I'm not the maintainer for this anymore, and I've learned a lot since I wrote this, but this is the Docker file on Hub. But also in addition, if you by sharing your, normally your Docker file lives with your source code. So most open source projects, I think there's like 30,000 open source projects on GitHub now have a Docker file. And we can see that as well as in Hub, if that's where you get your image, if you build your own, obviously you have the Docker file there too, which should be in, maybe in here, or admin scripts. Sorry, it's been a while. Okay, I don't remember exactly where the Docker file is for. Search, there's an idea. Well, anyway, it's not, again, it's not super important where, but normally you version your Docker file together with your source code because dependencies change as an application changes. So if you want to make a fork because you want to upgrade a big dependency, it's a bit risky. You take a feature branch, you update the dependency, you do your builds, you test, you make it stable, and then you merge it in. And then when you make that merge, on the master trunk, everybody gets the new dependencies, the new versions that you have tested in your own branch. We already looked at deleting, that should say images. So you can just as easily delete an image if you want to free up some space. In production environments, you will have some jobs that periodically go around and clean up old images. This is a normal thing to do because you don't want an endless supply of old images filling up your disk. Yeah, and then this is an easy way on your development systems, for instance, just to get rid of all your old containers. So let's talk a bit about how we share these images and like do Docker in a collaborative setting. We've looked at Docker Hub, so let's go ahead. I have a member, so if I go to my dashboard, let's create a repository, and I'm going to call it, let's have a look, what was my Docker image called? It was called My New App 1.2. Catchy, huh? That should work in marketing. Okay, so there I've created that. Now I have a repository. There's no tags, I hope. Nothing at all happening here. So, an important thing is that the thing you're pushing to should have the same thing as what you've called it on your machine. If that's not the case, you can create a new tag. So if let me just delete this repository. Okay, so say I want to create a repository, and okay, on my machine I call it My New App, but I want to give it the marketing name of Awesome. Okay. Now I have a thing called Awesome. So what happens if I try and push? That should be. So obviously some of the layers are already up there on the server, so it doesn't push things that are already up on the hub. It's another performance optimization that's being done. So this should not have worked. Not sure what's happening. Ah, maybe because I deleted it, it's still in the background actually doing the delete. Huh. I think we found an edge case for Docker Inc. Okay. So anyway, the point is, if you have called it something else than you want to push it as, you can just create a new tag from the image. It doesn't create a new image, it just has another tag that refers to the same image. Then you can push it. And you do that with the docker tag command.
If you create a new image, call it my app 0.2,
Hmm.
or 1.2, and you create another one called exactly the same, do you
Yeah.
overwrite your own? Or is it
You overwrite the tag.
you overwrite the tag?
Yeah. So the image layers are still there. So when you create an image, you give it the -t and then you give it the tag name, which is this, which is just like a branch pointer. It's like, that's the thing that I'm going to call this. So if you could make 15 things all 15 tags all pointing to the same image. That's normal. And if you overwrite it, you overwrite the tag. That's why I say tags are not versions really. They're kind of moving targets in that respect.
Is there a way for, if I want a particular version of the Ubuntu 14.04 and don't want updates anytime, is there a way for me to lock it into some, or can I control the versions I have in some way?
Yeah. So there's two ways you can do that. One is you can use your own registry. So you create your own registry and you control updates to that registry. We had some discussions at DockerCon about if there's a way that we can, instead of saying from a tag, we say from a SHA. And that's what I'd like to see happen, because then you can start to have proper configuration management. So I think the way most enterprises, businesses are doing it, they have their own registry, or they use Docker Trusted Registry, and they host it internally. I think that would become more and more common. Like if your organization is concerned about, for instance, they don't use GitHub because we want to have it all internal, then the same will be true for Docker Hub. You'll have your own registry internally. So let's call it so there we go. The internet's a little bit slow.
So what is the naming convention you do?
Docker push, and then you say what tag it is you're going to put. So exactly. So when I created the repository here, so when you create a repository, you pick Microsoft and then the name, and then it'll be like, I can only push to something Microsoft/. If I had different organizations or users, they'd all be in this list.
You need to push it to something you have created, a repository you have created in.
Yes. No. Seems like it will create it. Okay, that's new. But if you just push something, it will be automatically created. Another interesting thing for those of you that are running open source projects is that Docker Hub is an automated build system as well. So if you want to package your open source system in a Docker container, and you can specify the build process as a Docker file, which is what most Docker files are for, then Hub, you can set it up to automatically be triggered by changes in GitHub to build a new image. It's a really nice feature. I have to say, I was running a workshop at DockerCon on this, and they had some CDN servers were down, and or something, they couldn't talk to GitHub. So it might not be production ready. But for open source projects, it's good.
How does tags work when you go from GitHub? Is it tagged from the Git commit, or how do you specify the version?
Yes, I think that it's specified in Docker Hub, not in GitHub. When you set up the build, you specify when it builds what the tag should look like. And I think you can do some regular expression stuff so that if it's this branch, it should be this kind of tag. Okay, so now it should be up on Hub now. Yeah, there's my, it's one of you guys pulling my, who's pulling this? Okay, but now we should have a tag in here, 1.0. So we're getting a little bit short on time. I'll try and speed up a bit. Docker volumes. We said Docker containers should be ephemeral. They should be kind of stateless, restartable, all that stuff. And when they die, everything that they had is gone as well. But also, most applications that are interesting have some state. You want to put that state somewhere. But the idea is you don't put it directly in the container, you put it in a volume. So a volume is a directory in a container that's used for persistence. It survives beyond the lifetime of a container. Somewhere inside varlib, docker, blah, 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 there's a file tree where those files survive. By default, that's the way it works. You can also plug in different storage backends. So you could have a distributed file system. You could have something like Flocker. Lots of options there. You can map a volume to a host folder. It's considered bad practice. We'll come to that. And they can be shared amongst containers. Now, this is a really cool thing because a typical deployment scenario for an application, for instance, let's take a database. So a database, you have the data and you have the actual database application and all its dependencies. You would create a container for your database application. You'd have a data container for its data, and you would link those two containers together. And then what you can do is you can have other containers attached to that data container, for instance, for doing backup and analytics or whatever made sense in your system. The same is true for log files for websites. You probably have a data container that is your volume for logs, and then that is something you want to survive beyond the lifetime of restarts of your Nginx, for instance. I think we'll skip the command line for a little bit because we've only got 12 minutes. So the idea is that when you run a Docker container, for instance, here's running Nginx, and you're saying, in development, I actually want to take my local HTML directory that I'm currently editing and working on and map that into the Nginx HTML website directory so that you can basically do some development. And this is how you would do that. Now this is mapping from the host to the host file system directly, to a directory in the container. Now, I would argue that development is the only environment that you should do that for, because you don't want you kind of break a lot of the isolation properties of Docker if you say, yeah, but I'm always going to have to mount this directory on my host machine. You find that they'll become less portable, they'll be less scalable. There's a lot of problems with this. You can add volumes in the Docker file as well, so you don't have to run it. You don't have to specify it in the command line. You can specify it in the Docker file. You can say that I want to have a couple of volumes, for instance. You can use JSON syntax as well. So the best practices, containers in general should be ephemeral. You want to be able to restart them and move them around and scale them as much as makes sense. So in order to do that, you should avoid mounting directories from the host in production. And if you do have data, you have state in your system that you want to survive, then data containers are the best way to do that. Okay, so most interesting applications are more than one process, but Docker recommends one process per container. So how do you solve this? And that's with multi-container. This is multi-container apps. People doing, we call it microservices now, but it might be different depending on your system. It could be that you just have multiple services that you need to communicate with each other. Most interesting applications have more than one process. And this is kind of the marketing slide from Docker, and that's what they're talking about. Is like before, what you would do is you would have a big server, a lot of iron, that can take a lot of applications, and you would put them all on, and they would share a common user space, essentially. Now we're moving to smaller machines, possibly virtual machines in the cloud, running more isolated microservices. So what we can do is we can use Docker Compose to specify a multi-container app. We can do it on the command line just like before, and we can link and network containers individually. But once you have a multi-container application where all things need to be orchestrated together, it makes sense to use Docker Compose and a Docker Compose file to specify it. So here's a very simple example. We have an application with two parts. We have the build, the web front end, which exposes a port. It has a volume for our code, and it has a link. And the link is a way to say to Docker that actually these two need to talk to each other. And then with Redis, we have a second service called Redis, and it's using the image Redis. We have a two container application. Now, how that works and looks in practice is cats. So here's our compose file. We can do Docker compose up, and then it will create those two containers and connect them. It will use the default bridge networking. There's other ways to connect containers. We have a whole lot of interesting stuff happening in Docker 1.9, the latest version, in regards to multi-host and networking. So this is just the simplest explanation, but just know that you can go quite far with this. So now both my applications are running. You can see web and Redis are both there. We're getting output from both. And when I Control C to quit the application, then it will close all those. Sorry, it will stop all those containers. That's what I'm trying to say. Oh, not sure where that came from. We can also do a Docker Compose -d. So, up -d. So that is the same thing as starting those two containers, but it's starting them as daemons in the background processes. So if we kill one of those processes, the other one will not be killed. Actually, we can do Docker PS. We see Compose Web and Redis are running now. Compose Web 1 and Compose Redis 1, and these are the names they've been given by Docker Compose. So if I do Docker kill, yeah, let's kill, yeah, red doesn't matter. Yeah, doesn't matter. Kill is much more forceful. Stop will try for a graceful stop. I think it sends it's a different signal it sends to the application. I don't remember exactly which signals it sends, but yeah, this is just do it. You speak to these guys, they'll tell you. Okay, so now I've still got the web front end running around without a database. Not very impressive, but just so you know, they're different behaviors and different, whether you're running it in foreground or background. Yep, up -D, there's a typo. We can do, as well as doing PS, we can do Docker compose PS, so that will give us only the processes that are, only the containers that are running in terms of the compose file that we're working with. We can start and stop individual services, and we can remove individual services. We can also do some nice things like scale. Like, for instance, if we wanted to scale the number of web front ends, we could Docker compose scale and then give the name of the service we wanted to scale, and it would automatically spin up the number of containers to satisfy the constraint. And we can get the logs. Yeah. You can also specify a different type of compose file. By default, it looks for docker-compose YAML, but if you wanted to call it something else, you can do that. The new networking features in 1.9 are, you can access them by doing --x-networking, which is the experimental networking. It was experimental until a couple of months ago, but compose is catching. So just a final thought: the new things in Docker in the latest version are, well, we mentioned the multi-host networking, but there's also the multi-host clustering as well. And that's what's called Docker Swarm, if you ever come across that. So Swarm is the way that Docker suggests to create multi-host container applications. It's essentially a cluster technology. It's quite simple. So it really depends on your workload, whether this is the right solution for you or not. It's simple now. It will probably get complex as more and more features get added. But there are other options for creating multi-host apps with Docker as well, like Mesos and Kubernetes. We have Michael here from Mesosphere today. He's going to be giving a talk about how Mesos does it. And we had Kelsey Hightower. He's going to give the keynote later tonight. He's from Google, and they are heavily behind the Kubernetes way of doing things. And tomorrow, there's a full-day workshop on Kubernetes. There's still a handful of spots available, so if you're interested, go to the website and sign up for that. Yes. And actually, Docker Swarm can be used to point towards Mesos and Kubernetes platform infrastructure as well. So you can use the Docker Swarm technology to execute containers on Kubernetes cluster. Yeah, we certainly don't have time to go through how to set up Swarm because it's not very straightforward. Let's say it like that. But you can do it. There are good documentation. It is a bit new, so I think there's still a bit of rough edges on it. But it's an interesting development, and the speed that Docker is moving with, this is going to become very interesting. I'm not going to do a tour because my time is up, but one of the interesting things about Swarm and most of these clustering managers and schedulers is that they have different strategies like we're talking about. You can do bin pack, where you try and put as many on one server before you go to the next. You do spread, where you try and spread out your containers amongst them, so that if you lose one server, you don't lose as many services, but your resources are much higher. So it's a trade-off, and the ops guys are the guys that you need to figure out how best to schedule your workloads. So, some final thoughts. I think containers are quite interesting. I think Docker is very interesting. I don't even know if Docker is going to be the container technology in 15 years' time, but I think that containers are going to be around for a long time. And this kind of sums up why I believe this. I think that everything we do in computing is a trade-off, right? And we have applications running on hardware, and that, like, one hardware per application, that's very, very strong isolation. But in terms of the performance and utilization of our resources, it's quite poor. At the other end, you can have lots of different threads running who share a same memory space. It's a very fast, efficient way and lightweight for inter-thread communication and so But the isolation guarantees aren't there. So then at the process level, you get at least some memory protection. You get some help from the operating system scheduler. At the container level, you're isolated from the PID level, from the file system level, from many different aspects of the system. And further up the scale, you go to virtual machines where you have a whole operating system for yourself. So it's just a trade-off, and I think that the container's an interesting sweet spot for a lot of applications right now. I hope that we've covered quite a lot today in this session. I hope you got something from it. We went through these things. I just want to say thanks. If you have any questions, it's lunchtime now. Come and talk to me. I'll be here. Thanks.